Okay guys, in this chapter we're going to start areas of regular polygons and composite figures. And so this will start a big unit on area, surface area, volume, that kind of thing. But basically we're going to start with regular polygons. So remember, let's go back, way back to Unit 1. We talk about regular polygons. The definition, this of course is a pentagon. You can have a hexagon, octagon. Those are our most common ones. But also a triangle and a quadrilateral, a square are also polygons. So a regular polygon is when every side is congruent and when every angle is congruent. And so most of the time when you think about a pentagon, you're probably, what pops into your head is the image of a regular pentagon. So just want to talk about a few things here before we get talking about what the area is. So let's talk about a few parts of this pentagon. So we have the center, all right? So pentagons, just like circles, they have centers, okay? So there is a center, okay? This line here is called the radius, although we don't use it that much. It's not something that we talk about like we do in circles. But this line, and this is even more important, I think, this blue line, okay, from the center to a side that is perpendicular, okay. So from the center to any of the sides at a right angle, okay, then that is going to be called the apothem. The apothem. Okay, so kind of a weird word, but that's called the apothem. And so basically, these any polygon will have these two features. Okay, so there's not just one radius, there's not just one apothem. Okay, so in fact, we can draw more of these. Okay. So however many sides there are, whether it's 4, 5, 3, however many, 6, 8, whatever, however many sides there are in a regular polygon, that's how many radii you're going to have. That's also how many apothems you're going to have. Okay? So, if we want to find the area of this polygon, you should notice something quite useful that we already know. Okay, so you should notice something useful. We know how to find the area of a triangle, right? So the area of a triangle equals 1/2 base times height. Okay, so area of a triangle is 1/2 base times height. Now there are 5 of these. Right? So the area equals 5. There are 5 triangles, and if we can find the 5, if we can multiply, if we can find the area of one of these triangles, multiply it by 5, or as we showed in the last unit, we can multiply it in other shapes, not by 5, but by different numbers. I'll show you an example of that in a moment. But anyway, if we can find the 5 triangles, okay, then we can find the area. But you notice something. I just want to rearrange this briefly. 5b times h. Okay, I want to rewrite this equation like this. Now 1/2 is just 1/2. 5b. Okay, so imagine here's the base of a triangle. Okay, the base of a triangle. We might also call it the side of the polygon. But here's a base. Here's a base. Here's a base. Here's a base, and here's a base. So 5 of these bases, 1, 2, 3, 4, 5, we have another word for that. All of these added together is called the perimeter. Okay, so we can call this the perimeter. Okay, so that becomes the perimeter. And h, the height of the triangle, is the apothem, which we'll call A. Okay. So that is our general formula, 1/2 AP. And so let me draw, for example, a I'll draw a square, and I can draw I'll draw a hexagon as well. Okay, so just to illustrate this point, I'm going to draw, the same things here, just briefly cover it. Okay, so we have a center, we have radii, okay, and then we have apophthegms. Okay, so you can see there are four apophthegms, 4 radii, just like here. And we notice if we have, again, if we take, just running through this equation very quickly again, area of the triangles equals 1/2 base times height. But there are 4 of them, right? So the area of the triangle and then the area of the quadrilateral equals, there are 4 of those, so 1/2 base times height times 4. So I'm going to put the 4 right here. Okay. And so again, this is the base, the base, the base, the base, and the apothem is the height, so the area of the square equals 1/2 AP. Okay, same as this formula. Okay, let me just quickly run through we could do an octagon, I'll do a hexagon. And again, this equation only works with regular polygons, okay, regular polygons. So, okay, here's my regular hexagon. All right. Drawing in the radii. All right, there's my radii. So I have 6 triangles. Again, the bases are going to be all the sides. Okay. And so by the same logic, you guys can hopefully see that all of these, if we get bigger and bigger and bigger sided shapes, then there's still going to be the 1/2 times base times height times the number of sides. So all the sides together are going to be the perimeter times the height is going to be the apothem. So area equals 1/2 AP again. Okay. So it's all by this same logic that I did here, no matter what shape you have. So that is our general equation for areas of regular polygons. Now, I want to talk about what composite figures are. Okay, composite figures are quite simple, really. Composite figures are basically, so composite figures are basically when you combine the sides of 2 or more polygons. So when the sides of 2 or more polygons are joined or are put together. Okay, so let me draw an example of this. Okay, let's say we have a quadrilateral and a triangle. Okay, so if you want to find the area of a composite figure, what do you have to do? Well, you have to find the area of all the figures, right? Okay, this is not just polygons. We can also throw circles in here as well. So imagine if you had a semicircle here. Okay, so any sort of additional shape to this, you would just add up. We could put a pentagon down here. Let's see here. Maybe we'll put a hexagon. Okay. So anything like this, right? So you could find, if you wanted to find the area of this whole shape, you would find the area of this semicircle, the area of this quadrilateral, the area of this triangle, and add it to the area of this hexagon. And so there's no set formula for composite figures. Really, in this video, I just wanted to show you guys, sort of explain what a composite figure is. Again, you can keep making bigger and bigger and bigger composite figures. You can make a triangle here, as long as you're capable of finding each individual area, then a composite figure, you can find the whole area. And so that's what a composite figure is. In the next video, we're going to look at some different regular polygons, we're going to look at some composite figures, and we're going to find the areas of those shapes. Thanks for watching.